Let's have a look at question 2b. Now this is what we call a compound inequality. We've got more than two terms. We've got, so this is 2b, and I've got a 9 is less than negative 3y plus 4 times y plus 4 is less than or equal to 15. So my first job, I'm just going to restate that, and then I'm going to expand those brackets. So I'll do it step by step so it's pretty clear what I'm doing. So I'm going to end up with a 9 is less than, or negative 3 times y is negative 3y, and negative 3 times 4 is going to be negative 12, less than or equal to 15. Now, all I want in the middle here is a y. Yeah, I don't want anything else, just I want all the unknowns in the middle here. So let's get rid of the 12. So I've got a plus 12. I'm going to add 12 to both sides, add 12 to this side. Here we go. So now I've got a negative 12 and a 12 is 0. So I'm left with a minus 3y in the center. And I'm going to have a 15 and a 12 is 27. That works well. And I've got a 9 and a 12 is going to be a 21. Now, I've got, in fact, I'm just going to delay for a moment putting that sign in because I can see what's about to happen here. And what I want to do is I want to divide everything by negative 3. Now, when you divide an inequality or multiply an inequality by a negative, effectively you have to change the orientation, the direction of the signs, the direction of the inequality. So I'm going to divide this by negative 3, divide this by negative 3, divide this by negative 3. And the moment I do, this inequality has to be like there. It has to now be greater than or equal to, not less than or equal to. This one that was that way around, and this was less than this, or this was greater than that. Now I'm going to switch that around, and it's now going to be this is greater than this, or this, if you like. Sorry, this is less than this, or 21 over negative 3 is greater than the inequality in the center. Now I can simplify. I know that 3 goes into 21, or 3 sevens are 21, so it's going to be negative 7 is greater than y. That's exactly where I want y. And I got 3 goes into 27, although 3 nines are 27, so it's going to be greater than or less than negative 9. So there is my solution as an inequality. Now I have to state that, of course, express that on a number line. So here's my number line. I'll put a 0 in the middle. Now everything, in fact, is going to be on the left-hand side. So I'm just going to extend that out a little bit. So here we go. So let's put in 1, 2, 3, 4, 5, 6, 7, 8, 9. I didn't have to do that. I could have started this at negative 5 or something, but I'm just going to just do it so you can see where everything is in relation to a 0 here. So we've got negative 1, negative 2, 3, 4, 5. I'll put negative 5 there. Negative 6, negative 7 is my negative 7. 8, 9 is my negative 9, and so on. And we know that y, first of all, is less than negative 7. So it's going, here's my negative 7. It's going to be a circle around that, and it's going to be less than negative 7. So it's going to be on that side. But y is also greater or equal to negative 9. So if it's greater or equal to, it must have a solid circle around it. So there it is. So it could be negative 9, or it could be greater, or it could be nearly negative 7, but it's going to have to be less than negative 7. So we're going to have a line, solid line between the two like that. So that indicates it can't be negative 7, but it could be less than negative 7. It could be negative 9, but it could also be more than negative 9. So you might want to put that above the number line, and most people might do that. And that would be another way of stating it, expressing it like that. So either on the number line, I tend to put it above the number line. A lot of people will put it on the number line, depending upon what your teachers asked you to do. So that's how I would express the answer to this inequality. I hope that makes sense. And sorry about the dogs barking.